Good day everyone, this is Kyle. Welcome to episode 2 of Don't Memorize It, Derive It, a series where we derive various formulas that we may or may not have memorized in the past. For today's episode, we will look at the nuclear exponential decay equation. Where does exponential decay come from? Well, it comes from the idea that the decay rate of a radioactive substance is proportional to the amount of the radioactive substance that is present in our sample. In terms of mathematical symbols, that's dN over dt equals negative lambda n, where lambda is the decay constant, which is equal to ln of 2 divided by the half-life. The reason why the right-hand side is negative is because the amount of substance decreases over time, hence radioactive decay. Okay, this is a pretty easy differential equation that we can solve. What we can do is to multiply 1 over n dt to both sides to get 1 over n dn equals negative lambda dt. Then, we integrate both sides and we're left with the natural log of n equals negative lambda t plus c. We can then exponentiate both sides to e to get n equals e raised to negative lambda t plus c. We can easily separate then e to the c using the product rule, and setting e to the c to be equal to n naught, the initial amount of radioactive substance that we have, we're left with the final equation n of t equals n naught times e raised to negative lambda t, where n of t is the amount of radioactive nuclides after an elapsed time t, n naught the initial amount of radioactive nuclides, and lambda the decay constant. There we have it, the nuclear decay exponential equation that we're all familiar with. That ends episode 2 of the series. Don't memorize it, derive it. If you enjoyed watching that video, don't hesitate to like and share to your friends for more videos like this. See you next time!